to know the difference between experimental and theoretical probability. In this following table, we will highlight the difference between experimental probability and theoretical probability. So we will start to compare according to the definition. So the experimental probability is found be repeating an experiment and observing the outcomes. So you have to make actual experiment and then you are going to observe or you are going to write the outcomes. So the probability for any event, it will be number of times event occurs over the total number of trials. Example, a coin is tossed 10 times. If anyone is going to toss a coin, do you know the outcomes before you are going to toss the coin? I will repeat my question again. Before you are going to toss a coin, you will know the answer if the coin will stand on head or tail.
No.
No, you don't know, right? And is there anyone in the class now? Before you are going to toss the coin, you know the answer? Anyone? For sure, we don't know.
No.
But we know we can determine at the beginning that I'm going to repeat this experiment 10 times, 20 times, 30 times. So, which part we will know and which part we don't know before you will start any experiment. Before you will start any experiment, you have to determine what? You have to determine a number of times which you are going to make the experiment with. And you don't know the answer, but you know the outcomes. What are the outcomes? The outcomes, it could be head or tails, right? Because a coin consists of two faces, head or tail. So let's talk about this example. A coin is tossed 10 times. So what is the number, the total number of trials in this experiment? It will be what? The total number of trials in this experiment, it will be what?
10 times.
10 times, right? A head is recorded 7 times and a tail 3 times. So if there anyone can tell me how we are going to write the probability of a head, to get head?
We will make 7 over 10.
7 out of 10, because he recorded 7 times head and 3 times tail, then the probability of head, it will be 7 out of 10, and the probability of tail, it will be 3 out of 10. So this is experimental probability. What about the theoretical probability? Theoretical probability is what expected to happen based on mathematics. So the probability of event, number of favorable outcomes, the total number of possible outcomes. Then if you have a coin, so what is the total number of possible outcomes with the coin? What is the total? 2, because it could be head or tail, right? Head or tail. So what is the probability to get a head? How many heads? 1, yes. So it will be 1 over 2. What is the probability to get a tail? Is 1 over 2. Then the theoretical probability is what is expected to happen based on mathematics. How to find the experimental probability of an event? Number 1, conduct an experiment and record the number of times the event occurs and the number of times that activity is performed, divided in the two numbers to obtain the experimental probability. But how you will find the theoretical probability? The theoretical probability of an event is the number of ways the event can occur, favorable outcomes, divided by the number of total. What is the theoretical probability formula? So the theoretical probability formula, it will be the probability of event equal number of favorable outcomes over the total number of outcomes. Let's take an example. A bag contains 10 red marbles, 8 blue marbles, and 2 yellow marbles. Find the experimental probability of getting a blue marble. To make a marble from the bag, record the color and return the marble. Repeat a few times, maybe 10 times. So in this one, we have to make an experiment, right? And we said that we are going to repeat this experiment how many times, grade 7? We will
10
repeat the
times.
experiment 10 times. And what is the colors in this bag?
Red, blue, and yellow.
Red, blue, and yellow. Thank you. Then count the number of times the blue marble was picked. Suppose it's 6. يعني for example, you are going to repeat experiment 10 times and you picked 6 times, you have a blue marble. So the experimental probability of getting a blue marble from the bag is 6 out of 10, and we have to write it in simplest form. For the theoretical probability, we can find the theoretical probability. A bag contains, at the beginning, we said that we repeat experiment 10 times, right? Now we want to answer this question. A bag contains 10 red marbles, 8 blue marbles, and 2 yellow marbles. Find the theoretical probability of getting a blue marble. In this case, I will not repeat, I will not make the experiment, but we will use a theoretical probability. First of all, we have to know the total number of marbles. We have how many number of marbles in this bag? The bag contains how many marbles? The bag,
20.
how many?
20 marbles.
20 marbles. How did you find it?
Because the 10 plus
10
8 plus 2.
plus 8 plus 2. Thank you. So it will be 10 plus 8 plus 2. So we have 20. And how many blue marbles do you have in this bag?
8 blue marbles.
8 blue marbles. So how we will calculate the theoretical probability? We have the number of favorable outcomes, which was talking about how many blue marbles. So it was 8. And what is the total number of marbles that we have was 20. So in simplest form, it will be 2 out of 5. So if experimental and theoretical probability have the same answer, we were talking about the same bag, right? 10, 8, and 2. Do we have the same answer in both two cases, theoretical and experimental? The first one, the answer was how many?
3 over 5.
3 out of 5. And the second one we have 2 out of 5. Do we have the same answer?
No.
No, it's not necessary to have the same answer in both theoretical and experimental. Let's take another example. Find the probability of rolling an even number when you roll a die containing the numbers from 1 to 6. So first, is there anyone can tell me the total number of outcomes in this die? Total number of outcomes, it should be how many? You have a dice numbered from 1 to 6. The total number was 1, 2, Ruqayya. Ruqayya.
Yes, miss.
If you are going to roll a dice, do you know the total number? The total number, it will be how many? How many possible outcomes do you have? If you have a die, how many
It will
possible
be
outcomes?
6.
6, right? Because
It
you are
will
going
be
to count
6
1,
or
2, 3, 4, 5, 6, right? So we have 6. And how many even number from 6? How many even number?
3.
3, right?
3.
So the total number of outcomes in a die equal how many? Equal 6. How many even numbers?
3.
Please tell me what are the even numbers in this set of data? It will be what?
2 and
2
4, 6.
and 4, yes, and 6. How many even numbers do you have in this one? Their numbers equal how many? 3, right? Then we said that the total number of outcomes in a die was 6. But the even numbers 2 و4 و6. How many even number? How many even numbers? So we said that we have 3. So what is the probability it will be now, Ruqayya? So the probability it will be the probability of getting even. It will be how many? How you will
3 over the total.
Yes,
3
very
over
good.
6.
3 over 6. In simplest form, it will be 1 over what?
2.
1 over 2. Thank you. We can express the answer in 3 different ways. Is there anyone can tell me what are the 3 different ways which we can use it here? Huh? Ahmed Saber. We can express the probability by 3 different ways, which is
Fraction, percent, and decimal.
and decimal. Thank you. So we can write it as a ratio, we can write it as a fraction, we can write it as a decimal and as a percent. So we have how many ways we can write the probability. Dahrou, we can express the probability by how many different ways, ya Dahrou? Huh?
Yes, yes.
How many ways we can express the probability?
3.
Let's say 4.
What?
Let's say 4.
Okay.
We can write it in number 1, fraction, right?
Fraction,
Uh,
the decimal,
decimal,
ratio,
yes. Number 3, ratio. Number 4,
percent.
percent. Okay, so we can express the probability by using 4 different ways. We can write it as a fractional form, we can write it as a decimal, as a ratio, and as a percent. If there anyone don't know how we can write it in a fractional form or in a percent or in a decimal? Anyone don't know? Hassan. Hassan.
Yes, miss.
You know the difference now the difference between a theoretical probability and an experimental probability?
Yes.
Could you please tell me what is the difference between theoretical probability and experimental probability?
Yes.
Yes, tell me. What is
The difference.
What is the difference between theoretical? What we are going to do, ya Hassan? Hassan?
Yes, miss.
What we are going to do now?
We're going to ask the questions.
Going to compare between the experimental probability and theoretical.
Thank you, thank you. Okay, let's continue. I'll back to you again, ya Hassan.
So let's take a look at how those compare to each other.
Okay.
That spinner got 10 little slices here, and you can see there's some that are different colors. And then
So this is spanner in front of you. We divided it into how many parts? We divided it into how many parts? This is spanner, ya Ibrahim.
Yes, miss.
We divided this spanner into how many parts, ya Ibrahim?
We divided the spinner into
How many parts did we divide this spanner?
6.
6. Could you please count with me?
Miss, I have my screen freeze, so I only see the word.
Which word?
And Heather
Take
spent
me back again.
time. So this is experimental data right here. Okay, so this is what she came up with.
You can see well
Out of
now?
those 50 spins, one of
Still,
them came,
yes.
landed on yellow.
1,
Oh,
2, 3, 4, 5, 6, 7, 8, 9, 10.
10.
10.
So we have, this spanner shows 10 equally sized slides, okay? And we
Yes.
colored it with different colors. Ruqayya, we have how many colors in this spanner? How many colors you can see in this spanner?
3.
8? 8 colors?
3.
3 colors.
3.
Is, yes, I'm sorry. Which is?
Red and yellow and blue.
Thank you. So we have red and yellow and below, right? We are going to make an experiment with this spanner and we will record the outcomes. So a number of spins, we found that it stopped on yellow. How many times? How many times did it stop on yellow?
4.
4. This, if you want to calculate with theoretical probabilities, you have 4 times stopped on yellow out of 10. But we made an experiment and we spun this spanners and we found
It's
that
4 out of
in 21, right? And red we have 12 and below we have blue, sorry, we have 17. Then listen.
Red and 17 on blue. Okay, so here's the question. First of all, from Heather's results, compute the experimental probability landing on yellow. Now remember that the probability of yellow is going to be, and in this case, the experimental, it's the number of yellow out of the total. Right, so how many times did we end up with yellow? 21 times. And how many times did we spin it? 50. It says round to the nearest thousand. So of course, that means we've got to use our little calculator, and that's going to be 0.42, right? So our experimental probability of yellow is 0.42.
Okay, so in this part, we want to know what is the experimental probability to land on yellow. So we said in this case, what is the experimental probability to land on yellow? He said that we made this experiment 50 times and it landed on yellow in 21 times. So the experimental probability was 21 over 50. And we will change it into decimal part. Yes.
Miss,
Yes.
Miss, I'm in Rahma.
Yes. You just enter, Ya Rahma. You enter very, very late. Second part. A spanner, this spanner fail, compare the theoretical probability. What is the theoretical probability here in this question? What is the theoretical probability? How we will calculate the theoretical probability in this question? How many times it landed on yellow? It landed on yellow. How many times? For the spanner, how many times? 4 times. Out of how many?
10.
10.
Out of 10. Then to change it into decimal, it becomes 0.4, right? Now we want to compare. What do you notice about the two results? They are the same?
No.
They are not the same. So let's continue.
Another zero there, so you can see how they compare. Number of spins increases. We expect this experimental theoretical probability closer.
So if you are going to increase the number of times with experimental probability, the number of theoretical, it will be very close to the experimental probability. Okay, then you made the experiment for 50 times. If you are going to make the experiment with 100 times, with 1,000 times, so more increases of experimental, more accurate or more closer to the theoretical probability. Understood this point?
Yes.
Understood this point? So more times or increase the number of experiment, then the theoretical probability, it will be very close to the experimental probability.
Might not have options. The experimental and theoretical probabilities must always be equal. Well, come on, they're not equal here.
They will be equal?
They're automatic.
In this case, no. They not must be must be equal.
Anytime you see always pull that out. Here's another option we should consider. The number of spins increases. Expect experimental probability, theoretical probability on par. If you really think either, if we spun it once and we got yellow, the experimental probability of yellow in that case would be 1 out of 1. That means 100% yellow. That's not close to our theoretical, is it? If we spun it twice and we got 1 yellow and 1 red, then our experimental probability is 1 out of 2, 1 half.
Okay, so let's stop this with this part now. Understood what is the difference between theoretical and experimental probability?
Yes.
If they will be always are the same? Yes or no? Always are the same, theoretical and experimental probability?
No.
No, they are not the same. But more experiment, it will be closer to the theoretical probability. Now it's your turn. As I said, we have an evaluation now. Let me show you how you can find the evaluation.